Okay, this is our first part of the atmosphere series of lessons, and we're going to be talking about what is the atmosphere and what makes up the atmosphere. So we'll talk about all the different components of the atmosphere. So what's the atmosphere? Well, the Earth's atmosphere is the envelope of gases that surround the planet. It's like a thin layer or a blanket that's covering the planet. It's like a thin layer. This is kind of like the iPhone cover for the planet. Okay, so it just goes right around it. And so how is the atmosphere connected to the water cycle? Well, let's take a look. We just studied the water cycle, which we talked about the hydrosphere, which was all the water on Earth. And the lithosphere, we didn't talk about that word, but we did talk about Earth cycles, like the carbon cycle, or the oxygen cycle, or the nitrogen cycle. And those are all Earth cycles. So there's the lithosphere. And now we're talking about the atmosphere, which is talking about the air. Now they all have the ending sphere. And sphere is like a 3D round object, like a globe, like our Earth. Okay, so our Earth is shaped in a 3D spherical model. And because everything here is on Earth, it's all going to be spherical shaped. So hydrosphere, hydro, we know that's all the water on the Earth. Lithosphere, that's all the actual land on Earth. And the atmosphere is the air that's surrounding the Earth. And you see that when you take a little bit of everything, that creates the biosphere. So a little bit of everything creates the biosphere where every living thing can live. Okay, so the water cycle is included within this biosphere because it helps us live, and you have to have the accumulation and that is included in this hydrosphere, and then you have to have it go up to the atmosphere so it can evaporate, and then as it rises higher in the atmosphere, condense and form clouds. Eventually, you'll have that precipitation that will then fall down into the ground and can either be absorbed by ground as groundwater, or it can fall back into the hydrosphere again, so, into a pond or a lake or an ocean. So that's the connection between the atmosphere and the water cycle. So that's where we were, the water cycle. That's how we got to the atmosphere. And where will we be going next in science? We will be talking about the weather. And how does the weather then relate to the atmosphere? Well, the weather is the condition of Earth's atmosphere at a particular time and place. So when we study weather, we're actually studying the condition of the atmosphere, because we know that if it's a condition, it can change anytime and any place, especially in Ohio. So let's talk more about what this atmosphere is then made up of. So the atmosphere is made up of a mixture of atoms and molecules. So the atmosphere is made up of a mixture of atoms and molecules. And an atom is the smallest unit of a chemical element that can exist all by itself. And a molecule is made up of two or more atoms. So the Earth's atmosphere is made up of these different gases. You have nitrogen, oxygen, carbon dioxide, you have water vapor, And you also have other gases that we will talk about later. So the first gas that we'll talk about is nitrogen. Now, nitrogen is the most abundant gas in the atmosphere. So nitrogen is the most abundant gas in the atmosphere. It makes up 78% of the air that we breathe. So that's quite a lot of that, of nitrogen in the atmosphere. So abundant, if you don't know what abundant means, it means a lot. Okay, so there's a lot of this nitrogen in the atmosphere. Now the next one we'll talk about is oxygen. And oxygen is the second most abundant gas in the atmosphere. And it makes up 21% of the air we breathe. So how is oxygen used? Well, animals like us, we take oxygen from the air and we use it to release energy from our food. So oxygen can be used either rapidly or slowly, and this is how oxygen can be used rapidly. Fuel uses oxygen as it burns, and so it could be used rapidly in that way as a fuel. So examples would include like candles or even gasoline. We also know that oxygen can be used slowly. An example of how oxygen can be used slowly is when the steel in cars and other objects react slowly with oxygen to form iron oxide, or what you might know as rust. Now, most oxygen molecules have 2 oxygen atoms. Okay, so that would look like O2. So you have 2 oxygen atoms. Now, ozone is a form of oxygen that has 3 oxygen molecules, 3 oxygen atoms in each molecule instead of 2. So O3 equals ozone. Okay, now ozone is formed when lightning interacts with oxygen in the air. It splits the oxygen molecule, and you'll have a free oxygen atom that's moving around, and eventually it'll get picked up by another oxygen molecule. And that will make ozone, because then there will be 3 oxygen atoms attached to each other instead of just 2. Now, ozone often produces a pungent smell. So ozone often produces a pungent smell. And pungent means really stinky. Okay? Now, maybe you smell that outside after a big thunderstorm where there's lots of lightning, and you think, oh man, what's that smell? Sometimes I thought whenever I was little, that smells like worms. Well, actually what you're smelling is a scent of ozone, because that lightning has split those oxygen molecules in the air, and the free oxygen atoms have attached themselves to other oxygen molecules, making them have 3 oxygen atoms, which is called ozone. The next gas we'll talk about is carbon dioxide. And we know that carbon dioxide is essential to life because we studied that when we studied Earth cycles. So carbon dioxide is essential to life. We know that plants or producers must have carbon dioxide to produce food through a process called photosynthesis. Now, mammals give off carbon dioxide as waste. And burning fuel like coal and gasoline also release carbon dioxide into the atmosphere. We also have some other gases that are included in the atmosphere. We know that nitrogen and oxygen, they make up 99% of the air, because nitrogen is 78% and oxygen is 21%. If you add those together, you get 99%. Now there's just 1% left, and there's two gases that make up the majority of the other 1%. That's argon, which you can find in incandescent light bulbs, and carbon dioxide. So argon and carbon dioxide are the two gases that make up the majority of the other 1%. Now there's other gases that are included in that 1%, but there's just a teeny tiny amount of them. And those are called trace gases because only small amounts of them are present. And those include neon, helium, methane, krypton, and hydrogen. We also have water vapor that's in the air, and we studied that when we studied the water cycle. Now, water vapor is water in the form of a gas, and this is caused by evaporation. So evaporation, right, has vapor already in that word. There's also particles that are floating around. Now, pure air contains only gases, but pure air only exists in laboratories. So there's little particles in the real world that float around that are tiny solid and liquid particles. Of dust, smoke, salt, and other chemicals. Now, why is the atmosphere important? Well, Earth's atmosphere makes conditions on Earth suitable for living things. Or what's our fancy science word for living things? Biotic. So for living or biotic things. The atmosphere protects living things by providing warmth and liquid water, by blocking out the dangerous rays from the sun, and by preventing the Earth's surface from being hit by most meteoroids. And you have the pie chart down here. We know that nitrogen makes up the biggest part of that pie, 78%. Oxygen is 21%. The little sliver is called other gases, and that's 1%. Okay, so this concludes our first part that talks about the composition of the atmosphere. The next part will be the layers of the atmosphere, and you'll be doing a flip book that researches each layer of the atmosphere. So be sure to check your answers. Thank you for listening.